Okay, welcome back to the decision under risk lecture. Okay, where we were just addressing these issues. Okay, where we were addressing these issues. Now, we continue from where we left it at, and we are trying to build now a decision tree. Remember now what we were talking about when we mentioned about decision or chance nodes and square nodes, and square nodes were being were representing decision alternatives. So let's put a square node. This implies that we want to make a decision here. Okay, and what decision alternatives do we have? We have three, basically: maintaining the status quo, upgrading, and new building. Okay, here here's the first one. So you have that and that. I can put chance nodes there, a chance node, then a second one, put a chance node, then a third one, also. So I have put chance nodes here, meaning that each decision alternatives has certain chance nodes. So if at all we had maybe three different states of nature, like strong, moderate, and weak, so we'd have three chance nodes here. They would have three branches coming from each decision alternative. So this is a decision alternative to build, right? Then this is a decision alternative to upgrade. Okay, this is a decision alternative to maintain status quo. All right. So from these, we need to begin now ascribing their probabilities. We know that the probability based off the question, it's 40% when you have a strong market, right? So under your states of nature, you have two states of nature. Either when you have a strong market, which is 0.4, this is the one that is going up, or you have a 0.6 when the market is bad. Same applies to this one. When the market is good, you have 0.4, and when the market is bad, you have 0.6. We'll do the same, 0.4 and 0.6. So sometimes for each kind of investment, it might have its own probabilities. But in this case, we have they gave us one fit suits all, right? If that English is correct. So one fit suits all. So this size, the two probabilities are extended to all of the three different decision alternatives. Okay. Then what are the payoffs for each decision? What are the payoffs for each decision? So if you are building a new block, okay, if you are building a new facility under strong market, you have 70 as your net, okay, while you have 53. No, so let's maintain the building new. So building new, if it's weak market, you have negative 13. So this is still building. Now under weak market, which we ascribed 0.6 probability of 0.6, we are saying that it is negative 13, right? Okay, what about when you are upgrading? We know that upgrading is here. So we have a net of 53 under strong market. So we have 53. Then you have negative 5, I should think. Yes, we have negative 5 there. Negative 5. All right. So past that, we have status quo. So status quo doesn't change. We have 20 and 20 down there, right? Because you haven't invested your money. That has there's no investment there. Okay. Now what then do we do? So this, you are done. If we are just talking about decision tree, okay, basically you are done. Now let us go to expected monetary money. How do you write monetary value? All right, so this which is usually denoted by EMV. All right, so this, what is your expectation? What is the end goal amount for every decision? Now this is where we're going. So how do you do it? The basically general formula is for EMV is equal to so we're going to label these guys. So if this was our 1, this would be our 2, this would be our 3, that would be our 4. Okay, if we are our general formula is summation of probability of x. X would denote any decision alternative that you are looking at, and its payoff, basically the probability now of that particular outcome multiplied by the value, right? Or pay off. Okay, probability multiplied by payoff. So what are we saying? So for EMV, since our probabilities are here, so we can get 2. EMV2 is equal to that formula. Now, what is encompassed there? We have 0.4 and our payoff is 70. Our net payoff is 70. So we have 0.4 multiplied by 70. But remember, it's a summation, so you need to compass all the chance nodes that are involved on that particular decision. So we have 0.4 times 70 plus 0.6. Let's go to the table. So we have 0.6, this one, times negative 13. So 0.6 times negative 13. All right, we can go to the EMV3, which would be 0.4 times, what is the payoff? The payoff for upgrading is on a strong market is 53. So 53 plus 0.6 of negative 5, isn't it? Then if we go to the last one, which is EMV 4, it's a status quo. So 0.4, we know that the payoff has always been 20 plus 0.6, and the payoff there is still 20. All right, so you realize that this last one, 0.4 of 20, what is 0.4 of 20? You know that is 8, isn't it? Okay, plus what is 0.6 of, that is 12. So that will give us the 20 again. So meaning we didn't really invest, so we still maintain that status quo. What about the above? 0.4 multiplied by 53. That gives us 21.2, isn't it? Plus, what about 0.6 of negative 5? That will give us 3. So when we less that, what are we getting? When we less actually it will be negative 3, isn't it? Okay, so let us less that one from 21.2. What am I doing now? So 21.2 minus 3. That gives us 18.2, isn't it? Okay, we can reaffirm that 0.4 times 53, okay, plus 0.6 multiplied by negative 3 gives us 18.2. Okay, all right, we continue. Let us address another component. this one, which is 0.4 times 70. Okay, what is 0.4 times 70? That is 28. Okay, then what about 0.6 times 13? So that negative 13, I mean, so that would be negative 7.5. Okay, and what is 28 minus 7.8? Sorry, that is 20.2. All right. All right, so those are our values. So these we can input them into this now. So the result that we get, so this is EMV2. So on EMV2 we can write 20.2. On EMV3 we can say 18.2. On this one we say 20. So now these are feeding into the one decision. So 2, 3, and 4 are going to feed into this particular one decision 1, where you are choosing between building, upgrading, and status quo. So you ask yourself, between 2, 3, and 4, which one is bigger? So you say EMV1 is equal to greater of EMV2, comma EMV3, comma EMV4 bracket. So the greater of these three. So let us look at we have 20.2, we have 18.2, and 20. So the greater of the three is 20.2. So therefore the value of EMV is equal to 20.2, which is 20,200 if we are to bring back the zeros. So here, the value that will come here will be 20.2 because it is a greater of those. So what decision are you making? Henceforth, you are making a decision to build new and whatever this is. All right. So this is about decision trees, and basically that is a basic knowledge about decision trees. It cannot go beyond that. Of course, it goes complicated when you are looking at conditional probabilities and all that. But this gives you an overview of what decisions under risk are all about.